Hi, so this is Mr. Max with Sankofa Mathematics. So I have some questions on trigonometry and bearings, and I'm going to get right to the first one. It says, a regular hexagon is inscribed in a circle, and the circle has a radius of 6 centimeters. You are required to find the area of the hexagon. Okay, so let me just go ahead and do the following. Perhaps I just want to make it a little bit interesting for me. So I'm going to draw a line right through there. I'm going to draw another line right through there. And perhaps the last one from there to there. So what you should realize, remember the diagrams are not to scale. You should realize that I have 6 hexagons here. And another important fact is that the angles at the center, they add up to 360 degrees. So what this particular angle should equal to, we know that the radius here is 6 centimeters and 6 centimeters. So in order to find the angle at the center, there are going to be 6 of these angles there. So each little angle then there should be 60 degrees. Good. So once we have determined that fact, let me just bring my that distance over there. Okay. So once we have determined that our angle here should also be something like 60 degrees. So if that is 60 degrees there, then I can find the area of 1, and I'll use the formula to find the area of 1. It will be a half times AB times the sine of C. So the area is going to be half times 6 times the sine of 60 degrees. Well, you can go ahead and then you can work this out. You should realize that the area would be nothing but 36. Half of 36 is 18. So let me just put this here. Go back to that. So that's 36. So that's 18 times the sine of 60. Okay. And that is 18 times root 3 over 2, which gives you 9 root 3. All right, so this is the area of 1. You can go ahead and you can actually play around with it. Maybe you can write it to decimal places. So if that is the area of 1, then 6 of these triangles, because I have 6 of these triangles here. I have 1, 2, 3, 4, 5, 6. So the area of, in order for you to find the area of the hexagon, you'll have, say, area of hexagon will equal to 6 times, because it's 6 times this areas of that. Okay, so 6 times 9, it should be 54 root 3. So that will be the area of the hexagon. Okay, so just to make sure, the sine of 60. So get that sine of 60. Sine of 60 is root 3 upon 2, more or less, give or take. Well, calculator is not in the correct mode. It involves a little bit of more work in order for me to set up the correct stuff, but you'll get the idea. Okay, right. So now we have the area of the whole, so to speak, the whole hexagon. Okay, right. So I'll also not be, if I was to mark be a bit too strict on, suppose someone is not giving the answer, to the correct degree of accuracy, where you can also use your calculator, okay, and then you can give that maybe perhaps to whatever, 93.5, okay, that will be 3 decimal places, so maybe we can say or 93.5 centimeters squared. So that is also going to be an acceptable answer. You can also work with that. Good, so we now know what the area would be. So the area of the square. So the figure is not there, but let me just draw the figure. So you have a parallelogram. Okay. And let me just label it properly. So perhaps this is our N, capital letter, this is M, and that's L, obviously that's K. And we have also a little bit of that diagonal there. We also know that this angle here is 110 degrees. We know that this distance is 2x, and we know this distance is x. Right. So we also know that the area of the parallelogram is equal to 54√3 square centimeter. That comes from our previous answer in part A. Okay, so we also know that this line here, it divides the hexagon into, not the hexagon, but the parallelogram, into two congruent triangles, which means that the area of this first triangle here and the area of the next one, well, they are exactly equal. Right, so area of triangle NML will equal to area of triangle, well, you can write that down, equal to the area of triangle, well, NKL, which is equal to whatever that area of the whole thing is, divide by 2. So we have 27√3. Now the reason why that is important is because I'm going to use the formula of the area equals to a half times AB times the sine of C in order for me to calculate the values of 2x and x. So that means the area will be a half. Perhaps I should change that particular consideration. Bring in. So the area will be a half times x times 2x times the sine of 110 degrees should give me 27.3. Okay. So here you have, if you multiply this, you have 2x upon, this gives you 2x squared over 2 sine of 110 equals to 27√3. Okay. So eventually, if you clean this up, it's going to give you x squared equals to 27√3 upon sine of 110. Okay. So our x value will be the square root, okay, of whatever this answer is, 27√3 upon the sine of 110 degrees. Right, you can go ahead and then you can punch that onto your calculator. You should arrive at an answer that makes a little bit sense. So if I grab my own calculator here, so that's going to be 27√3, and that should be divided by the sine. When you deal with sine, you must make sure your calculator is in degree mode. Okay, so let's take square root, then fraction, so 27/3 over the sine of 110 degrees. So once I punch that onto my calculator, I get 7.0545 and so on centimeter. Therefore, x is going to be 7.05 centimeter. Well, this is correct to 3 significant figures. Okay, so make sure at least that you do get to understand how that particular question is done. Okay, so there is another question here. They say a building is 300 meters, the building B is 300 meters from, and this is the key word, the from, so maybe I should bring this a little bit in, from S. So it's B from S. So that means B from S, we have to go to S. And once we are there, so suppose that is my point S, and that is my point B. So this distance here, and what I'll know is that this is going to be exactly, let's get rid of that. This isn't coming out so nice. So let's just have it a little bit thicker. So this distance here, this distance there. Right, the bearing of B from S, so that means we have to go to what comes after the letter S. So after the letter S, we have this. So B from S, this whole bearing here, that's 240 degrees. Now, in order for the whole thing to make a revolution, this would have to be 120 degrees because it has to give you 360. Then this angle here would be 60 degrees because the angles between two co-interior angles, right? These two angles here, they should add up to 180. Okay, so now we have that angle. So the question is asking, find the bearing of S from B. That means we go to B, we go here. So the bearing is 060 degrees. Okay, I hope that everybody got that part. Right, so again, if we were to bring in our two little towns here, they say the bearing, so just to quickly bring in that, so this is our B, and that is our S, as it appears, and then I'm going to just join them here. So this point, that point joins, and well, we know this is parallel going to be. We also know that if we bring in our this angle here, we know it's 60 degrees. We also know that the distance between these two places is 300 meters. Then they say a spot T is due south of T, due south, due means exactly, due south means exactly 90 degrees south, so that will be in this direction here. Okay, just a little bit crooked, but you will get the idea. So let me just take that off. So that is going to be something in this direction. Okay, exactly 90 degrees. And due east of B, so east of B, it's going to be in this direction here. So what we're looking at is we are looking at the right angle triangle. Okay. We also can determine that this particular angle here should be 30 degrees because the whole thing should give you 90 degrees. Now they say find the distance ST, so our T would be here. Maybe it's not written nicely. Just our T nicely there. So our T, so we need to find this distance here. Right, so in order to find that distance, we'll have to use the sine ratio, and I hope you still remember your ratios. So it's going to be the sine of 30 degrees equals whatever is opposite, in this case, which is ST, over 300 meters. And in order for you to find ST, you simply say 300 times the sine of 30. And perhaps you can use your calculator in order for you to find what that answer is. Okay? Well, that gives you nothing but 150. Well, so I believe that's meters. Let's just make sure. If our distance was in meters, yes. So our distance is in meter. So the answer, correct answer, therefore, will be there 150 meters. Okay, so I hope that you have learned quite something here, and also it helped you a little bit with the revision work.